Assalamualaikum and good morning everyone. We are Group 6 and today we will present our use case of big data application in social media focusing on Facebook fake news detection and user behavior analytics. Our group members are AIDA, NATASHA, NURHANISAH, FATIN, and ALISA. In this presentation, we will explain how big data is collected, processed, and analyzed to detect fake news on Facebook and understand user behavior, as well as the insight on and challenges of using big data in this context.
Hi, my name is NATASHA binti Muhammad RUZAINI. For the introduction, I will explain what big data is, why is it important, and how it relates to our chosen use case. Big data refers to extremely large and complex dataset that cannot be handled by traditional software or databases. This type of data usually comes in massive amount, grow very quickly, and can be in many different formats such as text, image, videos, and user interaction. To understand big data, we use the 5 V's. The first is volume, the huge amount of data generated every second on the internet. The second one, velocity, the speed at which new data is created and needs to be processed. Third, variety, the different types of data including text, audio, images, and behavioral logs. Fourth, veracity, the accuracy and reliability of the data because not all data online is trustworthy. The last one is value, the meaningful insight or benefit that organizations gain from analyzing the data. Big data is important because it allows organizations to discover patterns, make better decisions, and solve problems that were previously too big or too complex. In our use case, Facebook fake news detection and user behavior analytics, big data plays a very important role. Facebook processes billions of posts and interactions daily, and big data analytics helps them identify fake news, understanding user behavior, and protect the platform from misinformation. That is the introduction to big data and how it connects to our topic. In this part, I will explain the main data sources used in our use case and how the 5 V's of big data apply to Facebook fake news detection. Facebook used several types of data. First is user-generated content, which includes posts, comments, caption, and shared link. This is the primary data usage to analyze whether information is real or fake. Second, Facebook collects metadata, such as the number of likes, shares, timestamp, user location, and device type. This helps the system understand how fast a piece of content spreads and how users interact with it. Third, Facebook uses user behavior data, like clicking patterns, reading time, and what type of content each user usually engages with. This helps identify which user or group are more likely to share misinformation. Fourth, Facebook uses external fact-checking data from organizations such as PolyFact and Snoopy's. This dataset label verified real and fake news, which are used to train machine learning models. Lastly, Facebook analyzes network or graph data, which shows how users are connected. This helps the system track the path of fake news and identify super spreaders. In terms of 5 V's of big data, first one, volume. Facebook processes billions of posts and actions every day. Second one is velocity. Fake news spread very quickly, so the system must work in real time. Third is variety. The data comes in many forms: text, images, videos, reactions, and behavioral logs. Fourth, veracity. The data has mixed accuracy because some information is misleading or false. And the last one is value. Analyzing this data helps Facebook detect misinformation and protect users. That explains the key data sources and characteristics for this use case.
Assalamualaikum and hi, my name is FATIN binti KAMARUDDIN. For our presentation this time, I will explain about big data ecosystem and technologies. To handle Facebook massive amount of data, several key technologies are used. These include Hadoop for distributed storage, Apache Spark for fast large-scale data processing, and NoSQL databases like Cassandra to manage unstructured data. Facebook also relies on graph analytic tools, machine learning models, and its internal Meta cloud infrastructure to support global data operations. Each of these technologies plays an essential role in the big data workflow. Hadoop and NoSQL databases store huge volume of data efficiently, while Spark enables quick processing so that real-time analysis is possible. Machine learning technologies help classify and detect fake news automatically. Meanwhile, Meta's cloud infrastructures ensure that data can be managed, analyzed, and delivered effectively to moderation teams around the world.
Now, I will explain the big data lifecycle in our project on Facebook fake news detection and user behavior analytics. Firstly, we start by collecting the data from multiple sources. This includes by the Facebook post and comment using ethical scraping via the Graph API and Selenium. All the data is anonymized to ensure privacy and compliance with the ethical guidelines. Once collected, the data is stored in scalable systems like NoSQL databases or HDFS data lake. This allows us to handle large volume on unstructured social media data efficiently. Next, we clean and pre-process the data. By text cleaning, remove noise, HTML text, and special character. We tokenize and lematize text to reduce variability and translate user comment into the post's original language. For the feature engineering, we create three main feature sets for our model, like textual feature from the post, sentiment feature from user comment, and engagement metric such as the number of likes, share, and comments. For the analytic and modeling, the process feature are then fit into our CNN or ANN model. The model has an in-binding layer, convolution and max polling layer, fully connected layer, and an output layer predicting whether the post is true or fake. For the feedback integration, one innovative aspect of our approach is integrating indirect feedback. Users' comments are aggregated to adjust the post truth level. Posts with the many negative comments are marked as a red, indicating this a high likelihood of fake news. Meanwhile, posts with the mixed feedback are orange, and posts with mostly positive feedback are green, indicating higher likelihood of truth. For the dashboard, finally results are visualized on a dashboard showing probability score, truth level, sentiment rate, and user behavior analytics. This life cycle illustrates how big data move from collection to actionable insight in our project.
Wabarakatuh. My name is NURHANISAH, and today I will explain on how big data analytics was applied. For the first one, Facebook data, post, comment, and share, analyzed using artificial neural network. In this study, the researchers collect large amount of Facebook data, including post, comment, and share, and these are huge data set that can change every second. To process and to analyze this data, a deep learning model that called as artificial neural network or ANN was used. ANN is very powerful because it can learn complex patterns that traditional methods may miss. And then the second one is linguistic and semantic pattern in the first were used as features. The model did not only look at the work, but it including language style, sentence structure, emotional tone, and the overall message of the post. And these linguistic and semantic features help the model understand whether the post is likely to be fake or real. The third one, neural network analysis, including how misinformation spread across users. Beside the content, the study also considered how fake news spread. Fake news usually move quickly across certain user groups or networks. By analyzing this spread pattern, the system gained better insight in into how misinformation travels and making detection more accurate. On the right side of the slide, finding or benefit from insight. One important finding is that ANN model perform very well with 89% accuracy. This means the model correctly identified a large majority of fake news posts, which is a strong result for real-world application. And then the second one is because of the system is built in big data tool and deep learning, it can handle and process massive amount of Facebook data quickly. The scalability is very important because millions of posts are uploaded daily. And then finally, the insight helped Facebook improve the content moderation instead of relying on only manual checking, which is very slow. And the model can automatically flag potential fake news, and this allows the platform to take action faster and reduce the spread misinformation. Next, I will explain on the challenge and ethical consideration. Firstly, data quality is a major challenge. It's actually very difficult to label something as fake or real news because people may disagree, and new type of misinformation appear all the time. This means the dataset may not cover every type of fake news, which can affect model accuracy. Next, we have bias and overfitting. The model learns from the training data. So if the data is not balanced or diverse, the model may incorrectly classify certain writing style. For example, posts with casual language or different grammar style might be flagged as fake even they are real. For scalability, real-time detection requires heavy computing power. The system needs to analyze millions of posts every minute, and that requires strong infrastructure. Without enough computing resource, the system may become slow or less efficiency. And the next challenge is privacy and governance. Since the model uses user post, comment, and interaction data, this information must be handled very carefully. Platform must respect user privacy and ensure proper consent when using personal data or fake news detection. Finally, there are ethical risks. One issue is false positive, where a real news might be incorrect flagged as fake, which is very unfair for the user. Another problem is the lack of transparency. Deep learning models are often black box, so it's hard to explain why decision was made, and this raises questions of accountability when the model make mistakes.
In conclusion, Facebook used big data to detect fake news and understand user behavior. By leveraging tools like Hadoop, Spark, NoSQL databases, and machine learning models, the platform can process massive amount of data and generate actionable insights. The full big data lifecycle, from data collection to visualization, ensures these insights are meaningful and timely. This case also highlights the importance of data ethics, privacy, and responsible governance when handling user data. Overall, it shows how big data can be applied to improve platform safety and enhance the user experience on social media. I think that's all from us. Thank you.